everyone. My name is Daniel Hiller. I'm a software engineer from Red Hat. I am mostly concerned with maintaining the KubeVirt CI infrastructure, so where our E2E and tests run, and not directly related to the development of KubeVirt, just for the automation part. So if you have any questions later on that you don't need to, or that you don't remember now, you can post them later if you want. You could probably ping me at Twitter or look at my GitHub account somehow. So what is this about? This is about Kubernetes and about virtual machines. Who of you is using Kubernetes already? Okay, a lot of people, although it's a little bit brightening here. So, and who is also using virtual machines somehow? A couple of people, okay. So, who has already connected virtual machines to Kubernetes containers? Okay. So, actually, that's what this talk is about. So, as I don't need to explain Kubernetes, I'm just going to spare you that. So the basic thing is, of course, that it's, as you all know, it's a software for running containerized workloads. And virtual machines, in contrast, need some kind of emulation and a hypervisor to run, which is not present in the Kubernetes cluster. So what would be if you could just put your old machine that is somewhere in the closet and just take it and put it inside your cluster, where you would then probably just could be able to turn it off when you need it, or turn it on when you need it, and turn it off when you don't need it. Or also, what would be or what benefit would you get when you would put your virtual machine inside a Kubernetes cluster and could let it talk directly to the containerized workloads? So most of the time, it's like you have something like a workload or a simple application that runs somewhere in a virtual machine, probably, or even on an application server somewhere, and you have the problem of connecting it to an existing set of workloads that are running somewhere else. And that's exactly what KubeVirt is about to solve. So, are there people that have already heard something about KubeVirt here? A couple of hands, I see. Okay. So, KubeVirt in general addresses the needs of development teams that process existing virtual machine workloads that cannot be easily containerized for whatever reason. I'd say, for example, you haven't had yet the time to containerize it. Maybe it's so critical that you just need to continue running it like that. But you still, most of the times, at some point, want to move somewhere else and want to probably get rid of that virtual machine stuff that you're running in a different set of environment, and you want to consolidate all this into one system. So you can get rid of those split paradigm of several environments that you need to manage. So what KubeVirt does is it provides a unified development platform that you can run application containers as well as virtual machines inside a common and shared environment. In short, KubeVirt makes it possible to manage VMs in the same environment as containers, and also just to manage VMs as Kubernetes objects. So I don't know if you can see that, but that's a virtual machine definition for KubeVirt. I just spare you the details of that. It's just like any other Kubernetes object definition. It's a YAML with a spec and with some attachments of drives, for example, and also with network definitions. and also with volumes that you can then just attach to the virtual machine. So much for theory. My story, when I tried preparing or tried imagining what I wanted to show here, was that I wanted to show probably how easy it would be to migrate a virtual machine into a Kubernetes cluster, so I thought. Yeah, the way would obviously be prepare the virtual machine for import somehow, so that it could run in a different environment. Then probably convert this disk image that you have into an importable format that would work with KubeVirt. Then import the image and create the VM, and of course success. So that would be the optimal way. But as you can imagine, it's not that easy most of the time. So first of the time, I failed a lot of times when I tried to prepare the VM to be imported inside VirtualBox. So I had an old virtual machine that I had set up years ago for my kids because we don't want to run any Windows laptops in our home. Or at that time, I didn't even have a Windows laptop, but my kids would have some learning program that they would use for school. So I had to set up one virtual machine where that learning program would run. Apologies already for that. It's just in German. If you have questions on that, if you need some explanations, I'd be happy to help you on that. But I guess it's just for the benefit of presenting something here. So I think we should be fine still by showing this in German. So first of all, the preparation for the virtual machine image was a real hassle. I worked a couple of months on that. So just to find out how to probably convert the virtual machine definition inside the image to align to what is currently supported by KubeVirt. So for example, this image was an old image that had configured an IDE bus as storage device. And IDE is just not supported anymore, of course, by KubeVirt because it's so old that it just doesn't support it. Also, Windows XP is an end-of-life operating system, of course. And for example, when you want to run it in any virtualized environment, for example, like in the virtual machine manager that is using KVM, you just even need to select this checkbox where you want to select your end-of-life operating systems. So normally it wouldn't even show up in that list of supported operating systems. So yeah, the VirtIO drivers I tried for using storage, but I didn't find any driver that would work with my old Windows XP. So I was totally annoyed, and I nearly tried to give it up and just to cancel the talk because I didn't manage it. That was very, very frustrating. But in the end, I had a solution just to convert this storage device inside the VirtualBox itself into a SATA device, and then it worked. But still, a lot of blue screens when starting up the virtual machine. But in the end, it somehow worked. So I think what, for me, worked the best, I still haven't figured out exactly what QEMU operating environment does to that virtual machine image, but somehow it magically worked. I don't know why. I need to figure that out, I must admit. Sorry for that. So the rest of the things was quite easy. Just to import the image into KubeVirt using the CDI upload proxy that is already present from the KubeVirt project was relatively easy, so that it would convert the existing QCar image into the target, I think it's raw format that is used by KubeVirt, and then create the VM. The creation of the VM was also not that easy because KubeVirt, as the processor model that the virtual machine would want to have, or wasn't provided by default on KubeVirt. So I had to patch the machine types that are present there that you can use. And then finally, it was a success. I had a running virtual machine inside KubeVirt with a caveat. The sound didn't work. I need to work on that. So, okay, I'm now going to start the demo. The demo environment I'm going to use is our standard KubeVirt CI environment that we're using in the clusters to run integration tests, or E2E tests even. It has enabled, these are a couple of Dockerized cluster nodes inside running locally. There are pre-pulled images to reduce the component spin-up time, and the enabled components I've used was a containerized data importer to enable the uploading of the images, RookSav as a storage provider, because you need block storage, and Prometheus and Grafana for monitoring. So, okay, since this will take a couple of, probably a couple of minutes, I'm just going to start the script that is going to import the VM image and tell you a little bit more about the project. So KubeVirt itself is an open source project that is in CNCF incubation state. It's been adopted by several vendors and end users. It has more than 3,500 GitHub stuff, 3,400, I'm sorry. 230 plus contributors, 800 forks, and more than 5,000 pull requests. So it has a monthly release schedule. At the moment, we're working on extending that a little bit. Also, it's tested on the latest 3 minor Kubernetes releases every time when you get a new release. And it has contributions from not only from RedHat, but also from companies like SUSE, NVIDIA, or ARM, just to name a few. So the features that I'm going to show are on the left side, like VM image import, live migration, snapshot and restore, monitoring, and serial. I'm just showing the graphical console access, to be honest, but it also has serial console access. So the other things that I wanted to mention was hot plug volumes and vGPU mediated devices, node assignment, cloud init, and sysprep. And what not unimportant, I would say, is a zero downtime rolling updates. So a couple of features the community is working on is, for example, memory encryption, multi-arch clusters, so that we have also, for example, ARM support inside a cluster that we have diverse architectures inside a Kubernetes cluster that we can then use for KubeVirt, several instances of machines. And another feature the community is working on is the VM export. It's pretty easy to install. You can just extract the latest version from the release, then apply a YAML, and the operator will do the rest when you're installing this. Now, I hope the import is already done. Yeah, it is. So I forgot, or I would have shown you probably that the import uses a scratch image to then convert the image into the real persistent volume claim that I'm using now. So I'm just going to show you now the already created virtual machine. So this is still starting, and it's still in scheduling state. If you see on the right side, is it big enough, or should I put it bigger? A little bit bigger? Okay, I'm trying. Yeah. That's better? Yeah. Okay. So I don't know, to be honest, why it's still staying in starting. I hope it's working at some point in time, because otherwise the next thing I'm going to do is just to create a connection with a VNC viewer to the virtual machine. When it's going to start. Otherwise, I need to resort to my recorded demo, which would be very sad, I'd say. Now it's running. Okay, fine. The demo god is with me. So, okay. So the virtual machine is still starting up, as you can see. And after a couple of seconds, we should see the Windows boot screen. And finally, have this virtual machine inside a Kubernetes cluster running. To be honest, I must admit, I didn't yet completely figure out the best configuration of the virtual machine, so to provide any hardware so that it wouldn't be thinking that it would have discovered some new hardware. I need to fiddle around with the configuration. So that's why the hardware assistant always nags me about some hardware that it has found somehow. And to be honest, the VNC viewer I'm using is also not really optimal. So let me see. I'm just going to try to. Okay, I think that's enough for this demo at least. So we have a running machine. So the next part would be that we would look at the metrics, the monitoring. So first of all, every KubeVirt component has metrics, like which you can scrape with a Prometheus instance, and you can, of course, put a nice Grafana dashboard on that. I've just put up this one just as an example. This is from the KubeVirt API component, where you can see lots of stuff that that makes sense to observe somehow. Also, of course, every virtual machine exports some metrics. If I need to reload here, I guess, and make it a little bit bigger probably, or decrease the time span, so that you can, for example, see the relevant measures that you need to look at when you want to observe your VM state somehow. So it has CPU image usage, memory usage, disk usage, and network traffic. That's just an example. You could probably just create a much more sophisticated dashboard, because all these metrics are exported via Prometheus, like I said, and you have lots of values that you could look at, and you could create some very fancy dashboards with that. So next thing I am going to show is creating a snapshot. So first of all, I'm just going to create a snapshot. So just to keep you a little bit in the loop of what I'm doing here, the snapshot object is a similar or also just a Kubernetes object that you're going to create on the cluster. And it then just stores the current state of the virtual machine while it's running in a snapshot. So now I'm going to do something like a destructive operation, if I can get to those. Yeah, that would be something that I would really appreciate if it would work somehow. Let me try to. Of course, it worked in the preparation of the demo, but now it doesn't work anymore. Sure. So let me see. I'm just going to remove some icons from the menu. Let me see some. If I find it, this one, then remove it, delete it. Yeah, of course, I want that. I would normally clean the trash can just to show you that it would be there already after I restore that. But for now, this should be enough just to show you the point of that. So one thing that you need to keep in mind is that you, of course, can't restore a running virtual machine. You have to stop it before you want to restore it. So that's what I'm going to do now. Stop Windows XP VM. So what you're going to see there on the upper left, there is the virtual machine status, which has changed to stopping. And the virtual machine instance will, after a while, go away. So the virtual machine definition itself still lives on, and you can stop it and start it as you want, but the instance, also the part that in general runs the virtual machine, will also go away. But that is just a technical detail. So, okay, then I'm just, one other thing I wanted to mention is, of course, that the VNC connection to the running virtual machine is, of course, going away when you're going to stop the virtual machine. So that's what you saw here, that the WebSocket was closed somehow. So now I'm going to restore the snapshot. And the restore is also just a Kubernetes object inside the Kubernetes cluster. Of course, you can also just observe the status of both objects with a normal kubectl describe. And then see, for example, here you see that the operation has already completed, so the snapshot has been restored. And then, if I find the VNC, yeah, of course, I need to start it. I'm sorry. So, as you can see, always the status of the virtual machine is always reflected in the respective Kubernetes objects that you're seeing on the right side. Like the virtual machine has its own status, and the virtual machine instance also has its own status. If it's then scheduled, then you can see, for example, on which node it will run, which will be interesting later when we are going to live migration. So it's running, so I can connect again. And we need to wait until it's completed starting up. And then we should see that the icons have been restored. Okay, so now I'm going to start the actual program that I installed for my kids on this machine. Come on. so annoying. So, okay, now we have something running here. And that will be already the last part of the demo. So now you see this is running, the program is running, and now I'm going to live migrate the virtual machine. Does everyone know what a live migration is? I see some nodding faces. Okay, I should have put it probably the other way around. Who does not know what a live migration is? Okay, a live migration is a migration of a virtual machine from one node over the other while it's running. So obviously that is very useful. Okay, so kubectl virt migrate Windows XP. I could also, of course, create a virtual machine migration object. Oh, okay. But I'm just doing it with the command line tool. This is, by the way, this is an integration so that it works with kubectl together as a plugin. There is also a separate binary that you can just use and download. So this is just another way to run this. So please look at the node name. You will, at some point in time, you will see on the right side that the status will change from running to migrating in the upper part, and the node name will change from node 01 to node 02. It takes a while. we lost already the connection, and then we see that it's migrated to node 2. Okay, now I'm going to open the VNC connection again, and the program is still running. So it has completely moved all the state to the second node. So that is already my, my live demo. So let me get back to the presentation. So yeah, my findings. I cut it a little bit short, but in general, the most work, from my opinion, because I'm not an expert in that matter, the preparation of an existing VM for import is the most effort from my findings. And very old VMs like Windows XP, which is an EOL, will of course make trouble when you're trying to find the right drivers that you need to install so that it runs smoothly. And yeah, for me, QEMU System x86, the binary that runs virtual machines inside Linux, has done wonders to just being able to start it inside KubeVirt. And to be honest, I still need to find out what happened there. And yeah, one last thing is I want to get the sound working. There is some option that you can enable so that you even have sound, but if I remember correctly, VNC does not support it by its protocol. But I think there is some fork that would probably then enable that you could even enable the sound on the virtual machine. But yeah, for business use cases, probably I guess you won't need sound. I don't know. Okay, that's everything for me. Thank you for your attending. Do you have any questions?
Firstly, let's have a round of applause. Thank you. We have a lot of questions. Luckily, we have a little bit of time. We have, I think, 8 minutes or so to get through these. So let's get right to it. Will it work with VMs that have multiple network interfaces? I'm not an expert in networking, I must admit, but I have seen that Maltus is supported, for example. So I think it should work. Okay. Let's tick that off. Where does the KVM image reside in the end in Kubernetes? Is it in some PVC? It's in a PVC, right. It's when you import it, it's converted to a raw image that is put inside a PVC. And that is just attached to the virtual machine definition just as a normal mount, you would say, just as a volume mount. Great. If I understood correctly, you're using a raw disk image for your demo. I'm sorry, I'm not familiar with QCOW2 disk format not supported by KubeVirt? No, actually it is. It is. QCOW is imported. I think there is also the support for VirtualBox images is already also, and you can use raw QCOW or. I'm not exactly sure what else is supported, to be honest. I would need to look that up. Okay. Oh, okay. And of course, that's when my phone turns itself off. Can pods from cluster access the VM or any service which is running on it? Is it any network visibility between this VM object and other pods? Yeah, of course. Because it's a normal Kubernetes object, you can just use the normal network definitions that you use for any other object. Great, that's easy. Like pod networking. Where is the snapshot stored? Was that was answered before, wasn't it? That I don't know, to be honest. Okay. I need to look that up. What is the most common use case for this kind of setup? Is there an application example? An application example for what? I don't really Why would you do this, I think is the general. Oh yeah, I thought I answered that. But yeah, in general, normally when you have some non-virtualized workload or a virtualized workload that is not yet containerized and you want to make it talk to containers. So anything that is still residing inside a virtual machine could just be easily transferred into Kubernetes cluster, and you would let it talk to the containers. Very nice, thank you. How ready for production is KubeVirt? I think there are quite a lot of adopters that are already using it in production. So, for example, OpenShift Virtualization is the downstream project of KubeVirt. And to my knowledge, it should be ready for production. Great. But even KubeVirt should be ready for production as of now. Okay. How are node failures handled, and are there any manual actions necessary?
I would say that you would probably try to, node failures are a little bit trickier, I'd say. I think that for now, you would probably need some manual interaction to migrate. The node failure itself, if the node goes away, then to be honest, I don't know what happens then. I think it's gone. So you would need to probably try to make regular snapshots and backups and just cover that. So
makes sense. Can I just drain a node and the VM will be live migrated to another node?
The live migration, I don't think it will work automatically, to be honest. And I think I don't know. I need to stumble.
Okay. Then we've got two others. For some reason, they're not showing on my app, but they're on the screen. Are affinity, anti-affinity rules possible?
Those are all possible. Right. You can. I forgot to mention, I guess, that the node selection works like in any other pod, for example. Like you would just would create a node selector or an affinity or anti-affinity rule.
Okay. And the last one from Chris. Thank you for not submitting this anonymously for once. Are still friends with VMware or other hypervisor vendors? ?
Why shouldn't we be friends? I don't know.
All right, well, on that note, let's leave it there. Please give another warm round of applause and enjoy your lunch.